using area models and multiplication to find equivalent fractions. So today we're still talking about equivalent fractions and using models to do it, but we're adding on multiplication. It says draw 3 different area models to represent one by shading. Decompose the shaded fractions into thirds, sixths, and ninths. Use multiplication to show how each fraction is equivalent to 1/3. So right here I have a model of one whole divided into thirds. Okay, so this is thirds. My job, we're being asked many things. They want 3 different models. They want us to decompose the shaded fractions into thirds, sixths, and ninths, and they want us to use multiplication. So the first thing I'm going to do is I'm going to try to decompose the shaded fractions. Now right now I'm going to shade in so that I can see 1/3. So far this is 1/3. And so that's my first model. I'm going to take the very same picture, 1/3, and now I'm going to decompose it by drawing one horizontal line across the middle. When I draw that horizontal line, what happens to this picture, and I'm going to make this a little bit straighter here. What happens to this picture is that I created more parts. There's 1, 2, 3, 4, 5, 6 parts that are same size. But the shaded parts, because there are 2, are now smaller. Whereas in my first model, 1/3 was this big. In my second model, the pieces are now this size. So they're smaller parts. So even though I took one thing and I made more, I multiplied it basically by making more and making that horizontal line. I made the pieces smaller because I have more pieces. So this is my second, and this represents 2/6 because I have 2 shaded parts and I have 6 total parts, which is my denominator. My third model is supposed to show ninths. I'm going to shade in. And now I'm going to decompose by drawing 2 horizontal lines. And so I need to draw those about 1/3 of the way down so that my picture's a little bit more equal. So again, I made more pieces. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces now, but my pieces are all even smaller than they were before. So we have a piece this size and a piece this size. So even though I multiplied it by making more pieces or repeatedly adding, I made the size of the pieces smaller. So even though I'm talking about a smaller fraction, I'm still talking about the same amount. It's just cut differently. And so the fraction I'm going to name, 3 are shaded, and there are 9 total parts. Now I'm supposed to use multiplication to show how each fraction is equivalent to 1/3. The first one's not hard. 1/3 equals 1/3. But let's look at this next one. We want to figure out how 2/6 is equivalent. What did I do in order to get 2/6? When I look at it, I divided each part, each third is divided into 2 parts. By me drawing that one line, that allowed that to happen. So basically, I took 1/3 and I multiplied it into 2 equal parts. The whole thing divided into 2 parts, the whole third. And so 2/2 is the same as 1. And when we multiply 1 by any number, we get that number. So 1/3 times 2/2 is essentially saying 1/3 times 1. We're just naming it differently. And so 1 times 2 gives us 2. That shows us our shaded parts. And then 3 whole parts divided into 2 or multiplied 2 times gives us 6 whole parts. So that shows us that 1/3 is equal to 2/6 because we just multiplied it by 1 and we got 2/6. Same for 3/9. I started out with 1/3 and I took 1/3 and I multiplied it, so now that there are 3 shaded parts. So here's my 3, and then I have 3/3 divided. I divided those into 3, and the shaded part is also in 3 parts. So here I have 3, 1 times 3 is 3, and 3 times 3 is 9. So I just represented it showing multiplication, and that is using area models and multiplications to find equivalent fractions.